Good morning, everyone. Welcome back to our natural language processing course. And today we will learn on chapter 5. It is about term extraction and wordnet. And here is the outline of our lecture today. First of all, we will review the basic term extractions that we have already learned in the previous chapter in chapter number 4. And next, we will take a look on feature extractions. When we say feature here, it's referring to some necessary terms that are important in the text. So we will see and how we can extract those terms. And we will use NLTK regular expression. And it is also known as touch pattern. And next, we will see on how we can extract noun phrase. Last but not least, we will see on how we can use wordnets in NLTK. Okay, now we come to the review part of our previous lecture on participate touching. So in here, as you take a look on this example, we have an input text, which is consists of 3 sentences. So we use triple quotes for representing those sentences in a separate line. And next, we use sentence tokenize to token them into sentences. And next, we use the function word tokenize to obtain the word tokens. Last but not least, we use the function post-touch for do post-touchings. So as the result from this function, we obtain the post-touching, which we can know the part of speech for each word in the sentence. So we also give the tables of list of tags which represent different part of speech. For example, we have VB, which represents a verb in a base form, and we have VBD for representing a past tense verb. And from the post-touchings, we can extract words that are functioning as nouns. So how we can do this? We can use these functions. So we need to go to loop to each word and position in the text here, and we check if this part of speech is in the form of NN or NNS, which represent a singular and plural nouns. And then we can get those information that are functioning as nouns. So now we will come to take a look on NLTK regular expressions. In the previous lecture, we also see on how we can use regular expressions. However, there are some little bit different syntax that is used in NLTK. So when we refer to regular expression in NLTK, we will first see the word chunking. Chunking, it is a basic technique which is used for entity detections. So when we say entity detection in here, we're referring to some terms related pair of words or single words that we want to detect. So in chunking, it segments and labels multi-token sequences. That means it can be a sequence of many words together or just some of them. And it allows us to know the sentence structures. So now we take a look on this example. We saw the yellow dog. So from this sentence, what information can we know from this one? So if we take a look on segmentation and label at both the token labels referring to the words and chunk label referring to the sequence of words, we obtain this information. For example, the first word is representing the personal pronoun. We have the verb saw, which is in the form of past tense. It is representing as VBD post, and so on and so forth for each word. And for the chunk label, for example, in here we have the yellow dog. It is in the form of noun phrase, which is starting with the determiner, following by the adjective, and ends with a noun. So from here, from post-touching, we get the word level tokenization, which is representing as a smaller box in this picture. And for the higher level chunking, which is represented in the larger box, we get those for term extraction. And in another term, each of these lecture box is also called a chunk. So now we come to take a look on regular expression, or we call it touch pattern. A touch pattern is a sequence of paraspeed tags delimited using angle brackets for detecting a pattern. So when we say delimited using an angle brackets here, that means we put the paraspeed tags in the bracket. For example, we have this format, we have determiner, and we use the special character in regular expressions. So basically, this symbol means an optional things, which can be either 0 or 1. And we have the adjective tags following by another special characters. This one represents 0 or many occurrence, and this ends with a noun. So this one is used for detecting a noun phrase. The rules that make up a chunk grammar, it uses text patterns to describe sequences of text words. So what does it mean? In here, when we define a text patterns, we want to obtain some sequences of words appearing in the sentence. For example, a noun phrase, a verb-noun pairs, or some other information. So this pattern is also called a chunk grammar. As we have mentioned earlier, touch patterns are also similar to regular expressions patterns. So here is a general way on how we can write a grammar for using in the touch pattern. We have to provide a name, and we have a colon for separating the names and the touch patterns. So in the touch pattern here, we need to enclose it in the opening and closing curly brace. So now we take a look on the examples of how we can write the grammar for regular expression. For example, in the first one, grammar 1, we have the name called NP, which is represented for noun phrase. So in noun phrase, the rule is that we need an optional determiners, which is this one. And it can contain any numbers of adjectives. So we have this one, which is representing for adjective, and it can be 0 or many occurrences. And last but not least, we have the nouns, which is either in a singular or plural forms. So in this one, we group them together using an opening and closing parentheses. However, we can also write the all syntax using this example in grammar number 2. We can enclose them, we can put them in the same angle brackets, just use the vertical bar. And the third syntax is that we can combine, we can have many chunks for a particular name. For example, in this one, this is obtained for the chunking P, and it can also in the forms. So there are two forms in this P chunking. So now we will take a look on noun phrase extractions. Consider on noun phrase chunking. When we are trying to search for chunks corresponding to individual noun phrases, the input of this one will be the post touchings that we get it from the output of post touching. So from here we have the words and its part of speech. And next we need to define a grammar that we can use for regular expressions. To be able to pass the grammar into the function, we use expression parser in this example. And for noun phrase that we know the rules for this one, it should have an optional determiner following by any number of adjectives and end with the nouns as we define in this grammar. And we need to create an LTK parser objects, which is obtained from this function. So make sure that we import an LTK first so that we can use the regex parser function. And next, what we need to do is to pass the tokens into the chunks. So the token here referring to the part-of-speech touching that is obtained from the above methods here. So we need to pass into these functions. So from these, we can know what is the sentence structures. So the result of returning from the pass functions, we obtain the three sentences. It gives us the information of the sentence. So S here represents the sentence, and here is the information in the sentence. So we trying to chunk it using a grammar defining below above, which is a noun phrase. So this is representing as a noun phrase. It have determiner, adjective, so any number of adjectives, right? So in this case, we have two adjectives and with a noun. So this it chunk it into chunks called NP, and we have another separated words, which is the word bark, ads, and some other NP chunking parts, which in the form is it does not contains any adjectives. And in another term, instead of seeing the three sentences in this string function in this format, we can also draw them into the graphical forms using the draw method. So from here, it gives us the three structures. This is the main sentence. So it chunks into the separate syntax structures. We have the noun phrase. It can be detected from our defined grammar, and we have some other verbs or prepositions, and it has another chunk which is represented as NP. Okay, now we will take a look on how we can chunk multiple sentences. From the text, it can consist of many sentences, right? So from here, we can use loop in order that we can go to each sentence. So this is just a normal, just similar to the other way, right? We just need to put them into a loop, and it will give us the same result. And next, we will use the text pattern to chunk the multiple sentences, chunk the multiple parts of the terms under the same name. For example, in here, we define a grammar, which consists of two touch patterns. It means that we can detect two types of patterns. The first one is follow this pattern. It has noun following by a past tense verb, followed by an adjective, followed by the conjunction, and ends with an adjective. And the second one is we have this form. So if we take a look on these word tokens, actually we can obtain these from word token function when we pass a sentence. And from these, what do we obtain? We have the output of this chunking, which is showing in here. We have the first sentence. So from here, we define a grammar called P, right? And we have this format. So as the results, this one gives us the rule for the first chunking part. And for the second sentence, as through here, we can match it using the second part of chunking in our grammar, which is have the noun following by a past tense verb and end with an adjective. So for the second sentence, we obtain these two of chunkings. So next we will take a look on word frequencies. So what is word frequencies? So in an LTK, it provides the frequency distributions which allow us to see the frequency of words appearing in the text. So what does it mean? We have a text, right? So we can know that what are the number of occurrings for each words in the text. It can allow us to know the context of the text as well by looking on the word frequency. For example, if the word appearing many times, we don't considering on the stop words, but some important verb, if they are appearing many times, we may think that the topic of the text is talking about the terms. Or it depends on our analysis. Sometimes when a word is rarely occurring in the text, we may think it is the main topic of the text. So it really depends on the factor in terms of analysis. So from NLT case, we can use several functions. For example, the first one we call frequency distributions, or in short, FRACDs. So we need to pass a word tokens. So it will find the frequency distribution for us. And if we want to plot the graph representing the word frequencies, we can use the plot functions. And we can also find the most appearing words that appearing in the text. If we consider on all of the text, it would be many, right? So if we're trying to find some most common number of words, we can specify in this function. So next we take a look on the examples. We can find the frequency word distribution. Suppose that we have these word tokens. We can also have a sentence, and then we use the word tokenize function to obtain these word tokens. And next we can go to show the information of the word frequencies in this word token using this loop. And then we try to access the number of words and also the word appearing for this in the sentence. So as the output from this example codes, we know that the word cats appearing 3 times, the word dogs 4 times, and there's only 1 for the word snake. So actually this is obtaining from the output of word tokens, as we have mentioned earlier. And if we trying to plot for these word tokens, we can use the plot function. So the result from this is that we have the 2-axis graph, the vertical axis representing the numbers of terms appearing in the word tokens, and we have the x-axis here, which is representing the terms, each term appearing in the word tokens. So we have the word dog, cats, and snakes based on the input of the function here. So from here we can see that the graphs going up at the dog word, right? Because it has 4 occurrence. And next we can also see this information in just a tabular format. So we can use the function tabulate. So it gives us the information in a table format. So we have the word dog, cat, and snake in just number for this word appearing in the text. So next we will see on the function most comments. The function most comment here, it gives us a list of terms that are appearing in the text. So if we provide the number 3, it will give us the 3 most frequently occurring words in the text. So how we can use this? So from this example, we have an input text. So we read the files, read the data using this function. And to take a look on each sentences in the text, we need to loop, because from this function, every line, it will return a list of strings, which is separated by a line from the text. So we need to go through each of them. So from here, we can use word tokenize and then to obtain the word tokens. And next, we can use the plot function to plot these graphs, which is representing all terms appearing in the text. So it will give us this information. And most importantly, we can also find the most common 3 occurring words in the text using this function. So as the result from here, we see what are terms that are appearing the most in the text. So as you can see in here, the word the, and comma appearing many times, right? As we discussed in the lecture on text reprocessing, we should remove some subwords, otherwise we don't know the context of the text. So in this example, subwords are not yet removed. So as the result, we see that most common words actually does not provide us any meaning, right? So a remark from here is that when we try to find the word frequency, we should do some text reprocessing first, make sure that subwords are removed. And next we will see on some useful function that we can use in Python. So we will test this in the Python cells. So you just simply open your CMD and then you type Python. Type Python here to go to the Python's shell. So you type some scripts there and then you can see the result of that command immediately. You don't need to run it through the IDE or some other code editor. So suppose that we have the data here. It is a list of words. So we can use the function join to join this array of words into a string. So if we join it with the empty space, so we obtain the strings getting from the array and we put the space for each of them. We can put some other symbols if we want to separate each word in the array. So we will find this function useful later when we try to work with an array and we want to convert it into a particular string. And next, in NLTK, we can also find the word corpus. So word corpus here referring to the all words that are appearing, that are containing in the corpus. For example, we can find the words that are ended with the ed. So how we can do this? After we import the NLTK, we can use the function nltk.corpus.words. This will access to the corpus in NLTK. And next we provide the language. So we want to get an English words. And we can sort those words into the ascending or descending order. So as the result of this codes, we obtain the list of words, right? This is in the sorted order. So we can count the number of words given from this corpus, which is about 235,000 words. And so these are just general words that we obtain from the corpus. So if we are trying to find the words that are ending with ed, which is the past tense, we can use the Python's regular expressions. We can search wherever it ends with an ed. So the dollar sign here representing as the endings. It ends with an ed. So we search for them and then we can obtain those past tense verbs. So as the results from here, we obtain about 9,200 words. And next, we can also use another shorter version of Python. Instead of doing this, this is called like a normal traditional way of writing code and loops, right? So some other version is that you can use directly in just only one sentence to obtain the word in NLTK corpus, and then you make it into an array. In the previous version in here, you need to have the variable initialized as an array, and next you need to append each words from the corpus into this array. But in this shorter version, it simply use only one line, right? You just need to loop them, and each time you make the word W here into an array here, which you pass in here. Okay, so right now we will come and take a look on WordNet. So what is WordNet? It is the lexical database. Basically, it is a dictionary for English language. It provides synonyms, antonyms, hypernym, which is a general word, hypernym, or we call it specific word, and it also gives us definition and examples of a particular word. How we can use this in an LTK? We need to import WordNet first. So either of the syntaxes work fine. From an LTK corpus, we need to import WordNet, or we alias the name into WN, so we can make it in a shorter version. So the WordNet corpus reader gives access to the open multilingual WordNet using ISO 639 language codes. So it does not only provide the English language, but some other separate language as well. So we can use these commands to find what language are supported. We can have English, we can have Japan, or some other language. So for more detail on WordNet, we can take a look on this link, which is the source of WordNet information. So next we will see on the term, we call it synset, hypernym, and hyponyms, which are used in WordNet. A synset is a set of synonyms that share common meanings. So that means when we have a word, this word can have many sense in terms of synonyms. And each synset, it contains one or more lemmas. So what does lemma here referring to? It represents a specific sense of a specific word. So remember that a synset, it can have many lemmas. And also the form of synset, it is identified with the three-part names. We have the words, and it has position, and it has the number. For example, if it is a noun, in a sense, number 1, it refers to a specific meaning. In the second meaning of this noun, it may refer to some other meanings. So now we take a look on this example. Suppose that we import WordNet before, and we alias the name as WN. So to obtain a WordNet, to obtain a synset, we use the function synset. So from here we pass some information. So we will get the syntax for this word. So in this syntax, if we use the go.antonyms here, it will give us an error because antonym is not appearing in the syntax code here. We need to do it with the lemmas. So a syntax can contain many lemmas, right? So we take the first lemma, and then we can find antonyms. And there are some more information regarding to the syntax. Syntax instances are the groups of synonymous words that express the same context. So what does it mean? It has many synonym words, right? However, they all express the same concepts in a particular meaning. And some of the words, it have only one syntax, or it can have many of them. And we will see this on how we can implement, how we can find the hypernym or hyponym of words, referring to the abstract terms, or we call it general terms, and we have hyponym referring to the specific terms. And next we will see on how we get the related information of a syntax. So from here we import WordNet, and next we try to find the syntax of the word travel. And from the syntax, it can have many syntax, right? So we just try to access for the first syntax in this list because it's returning as a list. And in each syntax, there are many lemmas as we discussed earlier. So we're trying to access one lemma, and we find the name. And we can also get definitions or example of this syntax. So we come back to this example. The output of this one will be if we use syntax.names, which gives us the name of the syntax. So it consists of 3 part names. We have the words, the part of speech, and the number. And what is the synonym of this one? So we have the word travel, because we take the first element. If we take the first or second element, it may appear in some other terms. And what is the meaning of these words? So it provides through this function definition. And we can also find the examples of these words using this function examples. So it will return us a list of examples. So for the word travel, the example is he enjoys sailing but he hated this travel. So next we will see on how we can retrieve all syntax of a words. Previously we have a syntax, and we just only try to access the first syntax. So now we will see how we can go to all the syntax. So we need to use a loop function. We need to loop for each syntax in the syntax obtaining from here. So we can loop them. So the result from this example code, we obtain a list of syntax for the word travel. And from this syntax, we can also find some other informations like the name of the syntax, the names of the lemma, definitions, an example. So the name of lemma here representing the synonym of this word. So the output of these examples will be, for example, we have the first syntax in the syntax list, which is the verb travel. So the information we obtain from here. And for the second one is this one. And the third one will be this one, and so on and so forth. So for the examples part, if the syntax does not provide us any examples, we will get those information as an empty array, as you can see for these syntax. And next we will see on how we get synonyms and antonyms of the given words. Suppose that we are trying to find the synonyms and antonym of the word first. So from WordNet we can use the syntax function. And next, as we know that for each syntax it has many lemmas, so we need to go to each lemma in the syntax. And next we can use the append function to add the lemma into our variables. So remember that lemma here is synonyms. So from lemma we can also find antonym if it exists. So we need to check using this condition. So if it exists, we need to add these antonyms into our list. So remember that there are many possible antonyms as well. So as the result from these example codes, we have the list of synonyms and antonyms for the word verse. As you can see from these outputs, some words are duplicated, right? Because the words, the syntax, it can have many meanings, right? In the first meaning, it may contain the synonym words. In the next syntax, it may also consist of these words. That's why we obtain the duplicated items. So to do this, we should remove whatever duplicated from our sample codes. So we just simply added some condition, right? So these are antonyms which are occur in the lemma. And next we'll see on how we can use similarity comparison using WordNet. So in WordNet, it also provides us how we can compare the similarity between two words, whether they are the same and what are the different. For example, it gives us a degree in the rank of score, ranging from 0 to 1. If they are completely the same, the score will be 0. If they are not the same, totally different, the score will be 0, for example. And it can also be in the rank, for example, 0.5 or 0.7, based on the algorithms defined by the WordNet. So to use this one, we need to find the syntax first. So this is the syntax which is storing in W1 and W2. And next we can use the function WUP similarity, which allow us to compute the similarity using the voice Palmer methods. So the WUP here obtaining from Palmer. So from here it returns a score, tell us how similar the two senses are, and the score is in the rank 0 to 1. So as you can see from these outputs, the score is 0.6 between this word travel and walk. And if you see the verb goat and zebra, it seems that the meaning of these two words are far away from each other, right? So from here, when we try to find the similarity between this one, the score is not much. It's only 0.09. And in addition to the WUP similarity methods, we can also use some other methods, and it also can be used in the another syntax. For example, in this one we use syntax 1 dot the function name, and then you pass the second syntax. We can also use word nets, and then we call to this function and we pass two syntax at the same time. This is just the two syntax that we can use for computing similarity. And now we can use this methods called pass similarity, which also compute the similarity score based on algorithm defined from the founder. So it will find the shortest path between the syntax in the hierarchy structure of the terms. And we can also have some other similarity methods. It is based on our context whether we compute similarity in terms of which factors. So for more information, you can take a look on this link on how we can implement some other methods provided from WordNet. And next we will take a look on another information that we can retrieve from WordNet. It is called verb frame. So what is verb frame? It is an indication of how verbs may be used. It's just showing us the verb phrase or collocation, for example. For example, in the entry for the verb facts here, we obtain these verb frames. For example, somebody, and these blank here representing the verb facts. So somebody facts something to somebody, or another phrase, somebody facts somebody something, or some other informations. So these are called verb frame. So to do this, we can obtain it from WordNet. We can access to the lemma, and then we call to the frame ID functions. So after we start from here, we can extract those information. And here is another example of how we can use the verb frames using the verb frame IDs. So this one is also just access to a particular syntax and then .frame ID. So next we can access to all noun syntax in the WordNet. So we need to use a function called all syntax, and we need to pass a part of speech. So here we use noun, and we take only the first 5 elements. And it can also be an adjective or verbs depending on our needs. And apart from this, we can also try to find the hypernyms, which is represent the abstract terms using the syntax.hypernyms. And if we want to find hypernyms, we can replace those information with this function. So the result from here will be the syntax and its hypernyms. Okay, so now we have homeworks. I hope you are doing fine okay so far. And to make everyone more sure about the lecture today, we have some homework for you. The first exercise is you write a program to extract verb-noun pairs, a noun phrase, and compound noun from text. So from text here, you can choose from your own example. It can be obtained from the internet or from an article, for example. And we notice that when we say a verb-noun pair, it can refer to any pair of words which is preceding with any types of word. So the verb here can be base form, gerund, past tense, or some other verbs format. And we have the noun. It is followed by a noun, which is either single or plural nouns. And the second homework, you use WordNet to get definition, example, synonym, and antonym of a word. And this word is input by the users. Okay, thank you everyone for joining the lecture today, and we hope to see you in the next lectures. Thank you.